Kev Randall here. This is a question from the OCR Core 1 examination in June 2007. It's question 1. The question is based on the expansion of brackets. So we've got 2x plus 5 all squared. So if we write that as 2x plus 5 times 2x plus 5 minus x minus 3 all squared. So if we write that as x minus 3 times x minus 3. Then we multiply the brackets. First times first, 2x times 2x, there, gives us 4x squared. Then we'll go 2x times plus 5, which gives us plus 10x. And the 5 times 2x, which gives us another 10x, plus 10x. And then the 5 times 5, which gives us plus 25. Minus x minus 3 all squared. We'll put that in a bracket, so this negative sign might be a bit troublesome. X times x is x squared. X times minus 3 is minus 3x. Minus 3 times x is another minus 3x. And minus 3 times minus 3 is plus 9. Now what we have to do is remove that bracket. So we'll rewrite this as 4x squared plus 10x plus 25. Minus x squared. Minus 3x is plus 3x. It's important that we get that right, that plus sign. Minus 6 is another plus 3x, and minus 9. So it's important we get the signs right when we remove that bracket. Then we collect the terms up. First of all, the x squareds. So we've got 4 there, minus 1x squared there gives us 3x squared. Just tick them off as I do them. Then the x's, we've got 10x there, plus another 10x there, plus a 3x there, plus another 3x there, which gives us plus 26x. And then the numbers, we've got a plus 25 and a minus 9, plus 25 there, minus 9 there. And that gives us plus 16. So we've expanded the brackets, simplified collected terms, and we've got in the form ax squared plus bx plus c. So that's our answer for 3 marks. So thanks for watching. Sure to look forward to the other questions from this paper, plus a few full papers that we're going to shortly. Thank you. For 1 exam from June 2007. This is question 2, and it's based on curve sketching, sketching curves from the equation of a curve. You will get this in the exam in one form or another. I've pre-prepared the graphs for ease of use. So question 2, it says, on separate diagrams, sketch the curve of 1, y equals 1 over x, and 2, y equals x to the power of 4. So first of all, y equals 1 over x, which is this curve here. If we look at that, if we take, first of all, put when x equals 1, we can see that y equals 1, which gives us this point here. Now then, as this is for y equals 1 over x, as x gets bigger, then 1 over x gets y gets increasingly smaller, but never gets to 0. So it comes along here and forms what we call an asymptote. So it's asymptotic to the x-axis. So as x gets bigger and bigger and bigger, the value of y falls towards 0, but never actually gets to 0. Here, as x gets smaller and smaller and smaller and smaller, then again the value of y gets higher and higher and higher and higher, but x never gets to 0, because when x is 0, then we've got a divide by 0 error. We've got y equals 1 over 0, which doesn't happen. If we look on the negative side, we're going to get x equals minus 1. So we've got y equals 1 over minus 1. Then y equals minus 1. So we get this point here. As x becomes more and more negative along here, it approaches the y equals 0, the x-axis, but never touches it. So it's asymptotic there, and it's asymptotic here. It never actually touches the y-axis. So that's a sketch of y equals 1 over x. For y equals x over 4, x to the power 4, that's this one here. Y equals x to the power 4. First of all, when x equals 0, we can see that y equals 0. So that's there. X equals 1. Y equals 1. We'll put that point there. X equals minus 1. Y equals plus 1. Then as x gets bigger, y gets bigger and bigger and bigger. So for instance, when x is 2, we can see that y is 2 to the power 4, which is 16 up here somewhere. When x is minus 2, y is 16. And as x gets bigger and bigger, for instance, when x is 3, we can see that y is 81. So we've got this curve here. So that's the curve of y equals x to the power 4. That's question 2 for 3 marks. You get 2 marks for that one and 1 mark for that one. So thanks for watching. Look out for the rest of the exam questions off this 2007 paper and also later papers. Caverandle here. This is the OCR June 2007 Core 1 paper. This is question 3, which deals with surds. It's a very popular type of question. It's almost certain to be on the exam paper. So be sure that you're very slick with handling surds, but it's certain to come up. So question 3 says, simplify the following, expressing each answer in the form a root 5. Because it tells you to look for root 5, it makes it much easier actually, because if you look at A, you start off with 3 root 10. Now, we can express root 10 in terms of root 2 times root 5, and that's multiplied by root 2. So there we've got 3 times root 2 times root 5 times another root 2. Root 2 times root 2 is 2, times 3 is 6, 6 root 5. So it's 6 lots of root 5, so the answer to that is 6 root 5. So there A is 6. And we get 2 marks for that. For B, again we know we're looking for root 5, so it's going to be fairly straightforward. We've got root 500, which is root 100 times 5, plus root 25, which is root 25 times 5, because 25 is 125. So that gives us root 100 is 10, root 5, plus root 25 is 5, so that gives us 5 root 5, and 10 root 5 plus 5 root 5 is 15 root 5. So that's the answer to part B. So we'll have 3 marks for that. Thanks for watching. Look out for the rest of the examples from the June 2007 paper and more OCR exam papers. Hi, this is Kev Randall. I hope this is going to help you with your OCR Core 1 examination. This is a question taken from the June 2004 Core 1 paper. It's question 4. It's based on the section on the discriminant of a quadratic formula. So what we have to do is evaluate the discriminant and say something about the number of roots. So first of all, before we look at the question, you'll recall the formula for solving the quadratic equation is x equals minus b plus or minus the square root of b squared minus 4ac all over 2a. Now the discriminant is this bit is the b squared minus 4ac. That's the discriminant, where a is the coefficient of x squared, b is the coefficient of x, and c is the constant term. So to go to the question, part 1, this is find the discriminant. Well, a is k, equal to k, the coefficient of x squared. B is equal to minus 4, that's the coefficient of x, and c is equal to k, constant term. So the discriminant is b squared minus 4ac, which is 16 minus 4 times k times k, which equals 16 minus 4k squared. And that's the discriminant. And that gives you 2 marks. So you get 2 marks for finding the discriminant. 2 marks there. Part 2. Again, it's just testing your knowledge of if you know what the discriminant is. If the quadratic equation has equal roots, it means that the discriminant is equal to 0. Now, if the discriminant is equal to 0, that means that b squared equals 4ac. So if b squared equals 4ac, we've got b squared is 16 equals 4k squared, which gives us k equals plus or minus 2. And believe it or not, we get 3 marks for that. So that's question 4 from June 2007. Hello, it's Kev Randall here with more help for your OCR Core 1 exams. This is the OCR June 2007 Core 1 paper. It's question 5. It's a differentiation question. It's based on a problem where you have to calculate maximum values and work out the maximum area of an enclosed space. So, just look at the question. It's a question worthy spending some time on because this kind of question comes up quite regularly. The diagram shows a rectangular enclosure with a wall forming one side and the wall in red there. A rope of 20 metres is used to form 20 metres length is used to form 3 remaining sides, and the width is x metres. So I've marked x on that diagram there. Questions first of all show that the enclosed area is given by a equals 20x minus 2x squared. And secondly, for 4 marks, we have to use differentiation to find the maximum value of a. Maximum value of the area, that is. So, where do we start? Well, we need to calculate, to find the area, we know that's x metres, so we need to calculate this distance here. Well, we know if the length of the rope is, this is for question part 1, we know if the length of the rope is 20 metres, and this distance here is x, therefore this distance here is x, then this distance here is 20 metres, which is the length of the rope, minus 2x. Actually, you get 1 mark just for saying that. Now we can reason then that the area then is going to be this length times that width. So the area is going to be x, the width there, times 20 minus 2x, and that gives us x times 20 is 20x, x times minus 2x is minus 2x squared. So that's the area. If we look at the question again, show that the enclosed area is given by 20x minus 2x squared. We've done that, that's good, so we get 2 marks for that. Part 2 says use differentiation to find the maximum values of A. So for part 2, well, where does differentiation come into it? Well, the area varies with the value of x. Yeah? As x changes, so the area changes. When we've got a maximum value for the area, then the gradient of the curve is going to be 0. So first of all, we need to find an expression for the gradient of the curve. Now if we've got a equals 20x minus 2x squared, which we've established there, then we can say the dx equals 20 minus 2 times 2 is 4, 4x. We do get a mark for that. Now, when the curve is at a maximum, I'll just go up here and just sketch this curve. If we've got there, we've got x, and there, up there we've got the area. When the curve is at a maximum like that, then the gradient is equal to 0. So the gradient is there, is equal to 0. So we can say at maximum A, which is this point here I've just identified, then the a by dx equals 0, so 20 minus 4x equals 0, which means 4x equals 20, which means x equals 5. We'll get another mark for that. So now we've found x. For the maximum area, we've found x, which is 5. So all we need to do is find the length here, there, multiply them together and we find the area. So we've got x equals 5. The length, well, we know the length of the row is 20 metres. So the length we're looking for is 20 minus 2x. Just check the diagram again there. It's 20 there, minus x minus 2x. So we've already worked out that x is 5 there. So 20 minus 2x is 20 minus 10, which equals 10. So there we've got on our diagram, just to reproduce it there, we've got that's 5 and that's 10. So the maximum area equals 10 times 5, which equals 50 metres squared. And for that we get another 4 marks. So that right, got that right, so we've got a total of 6 marks for that question on differentiation. It's Kev Randall, continuing the OCR June 2007 Core 1 paper. This is question 6, and it's based on the section and the specification which says equations which reduce to a quadratic. So this is one of those types of questions where we have to do a substitution before we can solve a quadratic. In this case, the substitution is given. So we've got, by using the substitution here, y equals x plus 2 all squared, find the real roots of that equation. Well, if y equals x plus 2 all squared, we can say that x plus 2 to the power 4, which is what we've got here, is y squared. And x plus 2 squared is y. So we can rewrite that equation as y squared plus 5y minus 6 equals 0. So we've used that substitution to reason that if y equals x plus 2 all squared, then x plus 2 all squared, which is y squared, is x plus 2 to the 4. And then we've got 5 times y, which is x plus 2 all squared, minus 6 equals 0. Now you'll find in actual exam questions of this type that generally this will factorise. So if we try and factorise that, we put a y in there and a y in there. Now we're looking at factors of minus 6 that add together to give us plus 5. This is minus 6, one's going to be positive and one's going to be negative. Because this is a plus 5 there, then we're going to get y plus 6 times y minus 1 equals 0. And if y plus 6 times y minus 1 is 0, then either y equals minus 6 or y equals 1. Now we know for our substitution that y equals x plus 2 all squared, which leads us to x plus 2 is the square root of y. So if x plus 2 is the square root of y, we can say straight away if y equals minus 6, then x plus 2 equals the square root of minus 6, which we can't have. So it must be this root here. It must be that value of y. So we can say x plus 2 equals root 1. So x plus 2 equals plus or minus 1, which gives us x equals minus 1 for one root, and x equals minus 3 for another root. There's a nice 6 marks for that. For getting that correct, we get a good 6 marks. So this is straightforward. When they give you the substitution, we make the substitution for y, square that to get our value of x plus 2 to the 4, solve the quadratic for y as normal. As I say, they'll almost always factorise, so it's an easy solution. Discard the negative root because we're going to find the square root of it, and then substitute to get the values of x. So that's question 6. Thanks for watching. Look out for the rest of the paper. Hello, it's Kev Randall. This is the June 2007 OCR Core 1 paper, and continuing with question 7. It's a differentiation question where we have to differentiate a function that's got a fractional index. It might be a bit tricky, but it's fairly straightforward really. And we use that to find the gradient of the curve at a given point. So part A is we've got, given the f of x, function of x equals x plus 3 over x, find the f dashed of x, the derivative of the function. So we've got f of x equals x plus 3 over x. The first thing we can rewrite that as the function of x equals x plus, well, 1 over x is x to the minus 1. So 1 over x is x to the minus 1. But we've got 3 of them, so it's 3x to the minus 1. So we can write that like that, and that allows us to differentiate it. So to differentiate that, for 4 marks, we go f dashed differential of x equals x to the 1, so differentiate that, bring the 1 down there, so we've got 1 x to the 0, which is just 1, and then multiply the minus 1 by the plus 3, so we get minus 3 x to the minus 1, not 1 off the minus 1 to get minus 2, so it's 3x to the minus 2. So f dashed is 1 minus 3x to the minus 2. Hello. It is. with you on the 8th. I had emailed you, but I can't make it. I've got an operation on the 6th, which I didn't know when it was. Well, yeah, but I don't know. Yeah, can you try and rebook it? The 5th, yeah, what? 2 o'clock is fine. 5th of February. What day is that? No, no, no. It's Wednesday the 5th at 2 o'clock. Okay, thanks very much. Yes, so you confirm that, will you? Thank you very much. Right. So that's 1 minus 3x to the minus 2, and that's f dashed of x, and that gives us 4 marks. Now the next thing we're going to do is, for part B, we're going to use that to find the gradient of the curve at y equals x to the 5 over 2. So we've got y equals x to the 5 over 2. So we're going to find the gradient, so we're going to differentiate that. So to differentiate that, we've got dy, using this notation now, dx equals, bring the 5 over 2 down to the front, so that gives us 5 over 2x. Knock 1 off that, 1 off the 5 over 2, which gives us 3 over 2. So dy by dx is 5 over 2x to the 3 over 2. Now then, when x is 4, to find the gradient, we substitute for x. X equals 4, so we've got an x equals 4 dy dx, which is the gradient, equals 5 over 2 times 4, that's x, to the 3 over 2, which equals 5 over 2 times, well, 3 over 2, 4 to the 3 over 2 there, means the square root of 4 cubed. So the square root of 4 is 2, and 2 cubed is 8. So it's that times 8. And 5 times 8 is 40. 5 times 8 is 40, and 40 divided by 2 is 20. So the gradient at that point is 20. So that's that. And we get another 5 marks for that, which gives us 9 marks in total for that question. So that's a fairly straightforward, good 9 marks. If you look for more of my videos on this paper and on the related topics, and thanks for watching. Thank you very much. Hello, it's Kev Randall. We're continuing with the June 2007 OCR paper. So we've got June 2007, it's a Core 1 paper, question 8. This question involves completing the square, and we use the completed square version to find the vertex of the curve, and then we solve an inequality. So first of all, if we recall that to complete the square, if we have an expression such as ax squared plus bx plus c, then to complete the square we can say x plus b over 2 all squared, minus b squared over 4. Well, b squared over 4 is b over 2 all squared. It's a simple way of putting it, plus the constant term. So that's the completed square version. So if we apply that now to the expression that we're given, so we apply that and we get x plus b over 2. Well, b over 2, b is, in our case, b is 8. So b over 2 is 4. That's all squared. Minus b squared is 8 squared, which is 64, divided by 4, which is 16, plus c, which is plus 15, which we're given. So the completed square is x plus 4 all squared minus 16 plus 15 is minus 1. So that's the first section. So for doing that, section 1, we get 3 marks. Part 2, it says, hence state the coordinates of the vertex of the curve y equals x squared plus 8x plus 15. Well, when it says state, in an exam paper, when it says state, you shouldn't have to calculate anything, you should just see it. So what we do, for the x coordinate, we change the sign, so the coordinates are minus 4 and minus 1. And we get 2 marks for that. Again, when it says state, if you find yourself having 2 calculations, you're probably doing something wrong. Because state means exactly what it says, just by inspection. Then question 3, part 3, says solve the inequality x squared plus 8x plus 15 equals 0. Is greater than 0, sorry. So we've got this expression now. We've already expressed this in a different form here, there, so we can now say x plus 4 all squared minus 1 is greater than 0. And rearranging that, we can get x plus 4 all squared is greater than 1. Now if we go ahead to solve that as we would solve a quadratic, we take the root of both sides, we've got x plus 4 is greater than plus or minus 1. Just if we try and imagine that in terms of a graph, we've got a quadratic graph something like that. We've got 2 roots here, there and there. Just to explain this, what we're looking for is when these values, and the value of this expression is greater than 0. Yeah. So we're looking for that and that. So if we just rearrange this, we get that x is less than minus 1 minus 4, which gives us x is less than minus 5. The reason we've gone from a greater than sign to a less than sign is because of the negative. So that is here. So if we say that would be minus 5, then we can say x is greater than plus 1 minus 4, so x is greater than minus 3. So that value there is minus 3. So that solves that in that inequality. And we get 4 marks for that. So thanks for watching. Look for the rest of the examples in this paper and more papers in the series. Hello, it's Kev Randall looking at OCR paper, Core 1 paper from June 2007. This is question 9. And the question is concerned with the equation of the circle and that of a straight line. So first of all, we'll start off with this equation. And we'll just rearrange it. Just rearrange the equation to get x squared minus 6x plus y squared minus k equals 0. So what we need to do with that is put it in a form that we can recognise to give us the centre of the circle. So we'll complete the square for the x squared minus 6x. So we'll get x minus 3 all squared minus 9. We've completed the square there. Add the y squared minus k and equate that to 0. Now we can see by inspection there then that the centre of the circle is going to come from that expression there. That's going to be the centre of the circle. X equals 3 and y equals 0 because we've got no term to add to the y squared. That gives us 9 plus k. So for the coordinates of the centre, again, we've got the x coordinate of 3 and the y coordinate of 0. Now to calculate k, we've got 9 plus k equals 16, and we get the 16 from r squared because we're given that the radius is 4, and that gives us k equals 7. So that's the first section completed. Section 2. To calculate the length of AB, we need the coordinates of A and B. So if we substitute x equals 3, in this equation, then that will give us the y coordinate. So that y squared equals 16, so y equals root 16, which is 4. Obviously it can't be minus 4, calculate it negatively. So the coordinates of A are 3 and 4. B, we're given the coordinates of B, minus 1, 0. So the length, the change in y and the change in x are both 4. 3 minus 1 is 4, and 4 minus 0 is 4. So then ab squared by Pythagoras, ab squared equals 4 squared plus 4 squared. So ab squared equals root 32. Sorry, ab equals root 32. And to come back, simplify the surds, root 32 is root 16 times root 2. Root 16 is 4, so the answer there is 4 root 2. Part 3 is find the equation for the line AB. It's a straight line, so we can look at y equals mx plus c. Now, first of all, we'll try and find the gradient to start with. Well, we know that we've just used 4 and 4 to find the length of AB using Pythagoras, so we know the gradient is 4 over 4, increasing y over increasing x, so the gradient is 1. So substituting that gives us y equals x plus c. And if we look at the point B, 0 for y equals minus 1 plus c, which gives us c equals 1. So the equation is y equals x plus 1. And that completes question 9. And there are 12 marks for question 9, so it's a fairly straightforward 12 marks. So thanks for watching. Look for question 10. Hello, it's Kev Randall. This is the final question on the OCR Core 1 Maths, AS Maths from June 2007. It's to do with solving an equation to start off with. So we've got this equation, 3x squared minus 14x minus 5 equals 0. And we'll look at the ways we could solve it. We could use the formula, but let's try and factorise it. It probably factorises. If we have two brackets there to factorise it, first of all, 3x squared, we haven't got much choice there. It's got to be 3x and an x, so we'll put the 3x in the first one, an x in the second one. Then we'll look at the constant term, which is minus 5. Now we know it's got to be minus 5 plus 1 or plus 5 minus 1. And there are 4 arrangements actually. A little bit of fiddling, a little bit of trial and error will give us 3x plus 1 multiplied by x minus 5. We'll just check that out. 3x times xx, 3x squared minus 14x minus 5 equals 0. Yes, wonderful, it works. So if 3x plus 1 equals 0, then that gives us x equals 1 over 3 for one solution, and the other one is if x minus 5 equals 0, then x is equal to plus 5. So and that's 3 marks just for spotting that factorisation. Second part, part 2, says sketch the curve. I've roughly sketched it earlier on. There's a y-axis, there's the x-axis, showing the intercepts. There are 3 intercepts I've got to show. The first one there is the first solution, there is minus a third. That's one intercept. The second one is that one, which is plus 5. And the third one is the intercept on the y-axis. And we need to do just a little bit of calculation to find that. So there we've got y equals 3x squared minus 14x minus 5. The intercept on the y-axis comes when x equals 0. So if we substitute x equal to 0 in there, we'll get y equals 0, 0 minus 5. So that third intercept for 3 marks is on y equals minus 5. So that's sketch the curve. You get marks for the 3 intercepts and for the symmetry of the curve. That's for another 3 marks. Section 3 is find the value of c for which that line y equals 4x plus c is a tangent to the curve. Well, we can equate the quadratic. Now 3x squared minus 14x minus 5 to the 4x plus c. Because the line y equals 4x plus c touches the curve 3x squared minus 14x minus 5. So as it touches the curve, because it's a tangent, we know there's only one solution. Just rearrange that, get 3x squared minus 18x minus 5 minus c, minus 5 minus c equals 0. And because the line is a tangent to the curve, it only touches it once, so there's only one solution. So if we hark back to our knowledge of the discriminant, we'll know that for that quadratic there, because there's only one solution, then, or repeating solutions we say sometimes, b squared equals 4ac, so b squared minus 4ac equals 0. That's a, that's b, and that is, just put the bracket around c. So we substitute for a, b and c in there, and we'll get minus 18 squared, that's the b squared, minus 4 times 3, that's 4a, times c. Now I've put c inside a bracket because there's a couple of negatives there and it might just get a little bit tricky. You've got to be careful not to drop a sign with this. The only difficulty, it's not really a difficulty, is there's a danger of dropping a sign. And if we work all that out and just collect terms, we'll find that c equals minus 32. And there are 6 marks for that. There's another way of doing it involving differentiation. I think that's probably the most straightforward. So there's a total of 12 marks. And that completes the June 2007 paper.